Namaskar. Today we will study the variation of molar conductance with dilution. By dilution we mean with decrease in concentration. Actually this topic was first of all explained by the three scientists Debye, Huckel and Onsager, and this was the work for which they were awarded with the Nobel Prize. So, the Debye-Huckel-Onsager equation was given by lambda m is equal to lambda m naught minus a under root c, where this lambda m is the molar conductance, lambda m naught is the molar conductance at infinite dilution, means when concentration is very low. This A is a factor which depends upon the type of the electrolyte, and this C is the concentration. So with the help of this equation, let us study the variation of molar conductance for weak electrolyte with concentration. For weak electrolytes, the graphical representation for weak electrolytes is like this. The graph is being plotted between molar conductance and under root of the concentration. This graph was obtained for weak electrolyte acetic acid. For weak electrolyte acetic acid, and when this graph is extrapolated, then it will be like this. It will not touch the y-axis. And here if we see, for this particular point, this is the concentration and this is the value of molar conductance, and when this point is reached, you see, for this point this is the concentration, and for this point this is the concentration, means concentration is decreased and molar conductance is increased. When there is a decrease in concentration up to this level, there will be increase in concentration up to this level. Means with a decrease in concentration, the molar conductance increases. And what is the cause? In explanation, we will explain that this is the weak electrolyte, and weak electrolyte does not dissociate completely when some water is added, but when we keep on adding water, then more and more ions from the weak electrolytes are produced, and due to more number of ions, the molar conductance of the electrolyte increases. So this is very simple explanation that for weak electrolyte with a decrease in concentration, means with addition of water, the molar conductance increases because more and more number of ions of the electrolytes are obtained. But when we study for strong electrolytes, then graph will be like this. have taken two strong electrolytes. This is HCl and this is graph for KCl. The graphical representation is showing that the molar conductance of HCl is greater than the molar conductance of KCl. Though in both the cases there are chloride ions, but the difference is here it is potassium ion and here it is hydronium ion or H positive ion. And due to the light weight of H positive ions, their mobility is higher and hence their conductivity is high. And when the graph is extrapolated, then we see that this curve will touch here on the y-axis, and this is lambda naught for HCl and this value is lambda naught for KCl. Means for strong electrolytes, molar conductance at infinite dilution that can be calculated. But for weak electrolytes, this graph does not meet the y-axis, so molar conductance for weak electrolytes at infinite dilution can never be calculated from the experimental observation or from the graphical representation. And now here the explanation for the behavior that when we see, let us take this point, this is the concentration and this is the molar conductance, and when we take this point, this is the concentration, means concentration is decreased, and this is the point, it means the molar conductance is increased. So in strong electrolytes also, with the decrease in concentration, there is increase in molar conductance. But here, for strong electrolytes, the increase in molar conductance is lesser. But in this case, the increase in molar conductance is higher. But the question is, for strong electrolytes, when some water is added, then these strong electrolytes get totally dissociated into the ions, and when more water is added, no more ions are produced. So how does this increase in molar conductance observe? So to explain this concept, we can say that when some water is added to the strong electrolytes, then new ions are not formed, but the old ions which were earlier formed, they get departed from each other, they get separated from each other, and interaction between the ions get decreased. And as the interaction between the ions is decreased, then their mobility increases. And when the mobility of the ions increases, obviously the molar conductance increases. So this was the explanation that why does the molar conductance of strong electrolytes increase with dilution. So this was the Debye-Huckel-Onsager treatment for weak electrolyte and strong electrolyte, and this was what the variation of molar conductance with dilution is all about. And now another aspect that for strong electrolytes molar conductance at infinite dilution can be calculated, but for weak electrolytes the molar conductance at infinite dilution can never be calculated. This was achieved theoretically by Kohl-Rash's law. This was achieved by the Kohl-Rash's law. So now we will explain the Kohl-Rash's law in the next video to understand properly that how the molar conductance at infinite dilution of the weak electrolytes can be calculated. Thank you very much.